We have Drew and Denise, Drew and Drody and Denise Buckley, product managers for Pollard Water. They cover our flushing, dechlorination, flow metering chapters. They each have their specialties, but a lot of them overlap. So they're very well versed in all the things that we're going to talk about today. Drew hails from the Seattle area, and Denise is in the upper Midwest. I think you've been through some rough weather a little bit lately, Denise, but I think maybe it's clearing up now. So we kind of cover all the time zones. Pollard Water covers the whole country. I'm on the East Coast, and so we're all over the place today. But thank you guys for coming on. And with that, I'm just going to be quiet and let these two do their job.
Thanks, Brian. My name is Drew and Drody. Been with Pollard for about 18 years. Been in the industry for 31, worked in the public sector for 13 years before jumping onto Pollard Water. In 2014, we became part of the Ferguson family. So your outside sales reps, Ferguson sales reps in your area work side by side with us, and we're in communication with them on a daily basis. So it's been a wonderful relationship, growing business, which translates, that much more product support for you, the end user, the customer. Ryan had mentioned I do manage our flow metering, our dechlorination, and our safety section, and Denise and I work together all the time. We back each other up, especially on the topic of discussion today. Denise, do you want to introduce yourself a little?
Hi, everybody. So glad you're here. My name is Denise Buckley, and I handle flow and pressure. That is my happy place. So when it comes to hydrant flow testing and different apparatuses and equipment and coefficients and all that stuff, I can definitely assist. I've been with Pollard for just over 6 years. I've been in the industry for over 20. Again, if you have any questions during this presentation, don't hesitate to interrupt and ask. That's how we all learn. Thanks, Drew.
All right, awesome. Hey, so in today's training, it's an introduction to hydrant flushing and flow testing. It is a good general overview. If there's anything in particular that we touch on that you would like us to expand upon in more detail, you're welcome to ask a question anytime, but also know that our contact information will be available at the end of this presentation, as well as your local Ferguson rep. You can get a hold of us at any point in time, and we can address any questions or application issues that you're experiencing on a one-on-one level as well. So please know that that is available. So we will cover today this evening, what is flushing? Why do we flush? When we flush? The environmental impacts of flushing, and what are the common tools, basic tools that we would need to perform our duties? Right, thank you. So when we're talking about flushing, there's really two types of methodology, two types of flushing out there. There's conventional, and I'll be honest, that's what I've always done when I worked at utilities, was conventional. And there's no rhyme or reason or specific order on our approach to the flushing. We went and worked an area, and we stopped at this hydrant, and where's the next hydrant or next blow off, and we'd work our map book and we'd work an area. And we got that area done, today. We may want to continue on in our same area tomorrow, or we might jump to another area, or we get pulled off. It's just something that was ongoing flushing, and it was effective, and we were able to accomplish our tasks at hand. But in the very end, when comparing the different types of flushing, maybe not as efficient and timely versus the other option being unidirectional flushing. Now, that is a term that UDF is becoming more and more prevalent in our industry, and that's where there is a methodology behind flushing. And it's the process of cleaning water mains in our distribution system, flowing in one direction, typically from the source outward, from larger mains to smaller mains. And it is can be a little bit overwhelming. A UDF program is something that you would develop initially, and you start small and it grows, and you'll learn as you go. and you have to break it up into small chunks. It requires a lot of pre-planning and looking at your maps, your as-builts, your hydraulics of your system. Depending on the topography of your system, you've got different elevations that you have to work with, so pressure zones and such. So, and you might have a wellhead, multiple wellheads, multiple sources or tanks of water. So you might have to approach this in multiple directions and in, systematic chunks. So understanding your system, the hydraulics of your system, that will help you start page 1. Moving on and understanding too in unidirectional flushing, one of the key factors that AWWA recommends is having a minimum flushing velocity. And when we're talking velocities, we're talking the scouring power of when we're flushing our water mains, breaking off any tuberculation inside your water pipes, whether it be iron or any other mineral or sediment, keeping them clean and making sure that our water is flowing properly. So AWA recommends a minimum of 2 foot. I'm seeing a lot of municipalities throughout the US meeting that and or exceeding it. I see a lot of people that are stating, 3 foot per second. And that typically will equate out to, on an 8-inch main, a 3 foot per second velocity is roughly, 520 gallons a minute. So it's just trying to, if you're going to flush a main at 100 gallons a minute, it's not going to be as effective as if you're flushing a main at 500 gallons a minute. That makes sense. So that's all that they're stating, is you really need to have the flow, how fast that flow of water in order to get the appropriate scouring power in your water mains. This is just a simple algebraic formula. This is not a math class, but Q equals VA, flow rate, velocity, area, pipe. If we have an SOP of 3 foot per second for our UDF program, we can, and we know the size of pipe, we can figure out the area pipe, then we can figure out what our flow rate is. So it's a real simple algebraic equation that we can, in developing our UDF program, we can outline a simple chart for, depending on what size main you're working on, what that ideal velocity would be. So next slide. Now, something that goes hand in hand with UDF programs, unidirectional flushing versus conventional, is when you do UDF, you are working systematically from the source outward. So you are on every valve, every hydrant. You're working in every zone. So you can theoretically develop and start doing hydraulic mapping and data collection. And it would work hand in hand with maintenance as well, which we'll touch on in a minute. Since you're going to be opening every valve, making sure you have access to it, making sure you can find the hydrant. It's somewhere here in this, side of the road, but it's just engulfed in blackberries, trying to be able to get to that. So hydraulic mapping, data collection, someone definitely, you'll know your system in and out and every valve location for someone who manages a unidirectional flushing program. We'll touch more on hydraulic mapping a little bit later on with Denise. Next slide. So why do utilities flush water lines? Obviously, it improves the water quality. We're out there, if we get a phone call and they've got cloudy water or a rotten smell of the water, all of these things, customer complaints, color, taste, odor. We want to improve water flow. So if we've got a decrease based on our flow testing we do annually throughout our district, if we're seeing a decrease in our flow capabilities, we could look at, well, what type of water mains do we have? What is the age of our water mains? And what is the condition? How long, when we do our flushing programs, how long does it take from at each location to, start a flush to finish a flush in order to move on and pass the water quality at that point in time? All of these can be an indicator and directly affect the water flow. Managing chlorine residuals. This is another really big one, especially during summertime or even wintertime. At the dead ends at our furthest points in our distribution systems, it's hard to manage chlorine residuals because there's not enough water flow. So in summertime, the chlorine residual can get eaten up, or in the wintertime, it could just dissipate because of the long time that it's been sitting there. So there's a couple ways you can look at it. every utility has got dead ends, and we always try to engineer those out and loop our systems. So because that directly affects our water quality, but we still got them. So there's some, we might have to be out and flush those dead end mains 3 or 4 times a year versus one time for the rest of our distribution system. And there's some things we can address for dead end mains and that at a later time. But managing chlorine residuals is important. Make sure we have a safe drinking water supply from the source to our furthest point. Other reasons why we flush our water lines, we had touched on maintenance issues. Defective or inaccessible, so hydrants, valves, blow-offs. I think most municipalities have got, what, a 3-foot radius around fire hydrants that have to have access for fire department, for utility workers. We need to be able to access those fire hydrants and operate them. We've got a hydrant wrench that goes around the top of the bonnet, so we need to have a clear area for us to operate, to take the caps off and hook hoses up. So that becomes always is a maintenance issue in itself. Next slide. I'm going to pass this over to Denise at the moment. Denise?
Got it. Thank you so much, Drew. Does anybody have any questions before we move on? I will take that as a no. So another reason why do utilities flush water lines, to hydraulic mapping. So we'll talk again about that in a little more detail and give you some ideas on how to set up a system and help you so that you can pull all the data and make your life a little bit easier. The first time you do it is a little tough, but every time after that will get easier and easier, and your record keeping will be so complete. It's a great way to learn your system and learn where your weak spots are. Also, we're going to talk about flow testing and what information you need to do a complete and correct flow test. We're also going to talk about data logging and how data loggers can help you and provide data and feedback for you to help you find potential leaks in another part of your weak systems. Next slide. Thank you. Ryan's on the ball. I love it. All right, so considerations for flushing. You want to look at the basic common sense things, we call these. Temperature. You're not going to do this in the middle of winter. You're not going to do it when there's ice or frost. You're not going to do it when it's 95 degrees out. We want to save our guys, our crews. We don't want them to get injured. So, normally you do spring and or fall flushing. A lot of municipalities flush twice a year. Again, it depends on your system. It also depends on your manpower and how often you do it. Someone had made a comment that a lot of you guys are fire department. So if that is true, then your system may be a little bit different than the municipal department because you have less manpower to pull equipment out of the station and have 2 guys out at every hydrant versus 1. So we can definitely talk about some of those ideas too. Next slide. Other things to consider is where your system lies. If you're going to do something in the middle of the night, which is sometimes easy to do because you have less interruptions for your residential customers, but you also have to look at the roads, and are all of your customers parked on a road where you're not going to be able to get to a valve or a shutoff or something in case you need it. Also, depending on what kind of draw you have on your mains for industrial sections. And these are things that you probably already know, but when you do this, you're going to find out more information too, and you may tweak your system here and there to change your times and things like that, just to make it easier. So again, a lot of these are just common sense, but they're things that you want to keep on the front burner so that you can set this up the first time as painlessly as possible. Drew?
The other consideration that's really become prevalent last decade has been dechlorination. So on a federal level, it's been recognized that utilities flushing water is a requirement for water quality. It used to be there was a mandate, so I'm sorry, you just cannot discharge chlorinated water. Sorry, no go. But they said, wait a second, municipalities, PUDs, this is a standard practice for us. We have to, from a water quality standpoint, and these are the reasons. So the Clean Water Act is the federal regulation that actually dictates our dechlorination levels, and we'll touch on that here in a second. So federal level, we always have to follow that. That is the most stringent, or that's the most basic requirement. From there, states, counties, cities, PUDs, associations, you name it, can make those regulations more stringent. They just cannot make them more lax. So at the very least, according to the federal regulations, we have levels prescribed to us whenever we discharge potable drinking water, or as part of our practice, whenever we discharge water into the environment, we have to make sure we dechlorinate that. An acute being short term, an emergency situation, and there's a little bit of flexibility with the emergency. There's still due diligence that's required. Maybe not the first, it might be the third or fourth requirement, but we still need to have due diligence. So what this means is for short-term exposure of releasing of chlorine, it cannot exceed 0.019 milligrams per liter. Same thing as parts per million. Milligrams per liter and parts per million, synonymous terms here. Long-term is the chronic exposure. So long-term, we cannot let anything over a 0.011 milligrams per liter of chlorine being discharged out in the environment. And that's, these levels are really low. They, in all essence, they're zero, right? So we might be able to get to that tight of a resolution on a really high-end colorimeter, but test strips and your basic colorimeters are only going to go down to hundredths of parts per million. So this here is really down to an untraceable amount of chlorine, and that's really how we need to look at it. So finding the right tool for the job, finding the right chemical based on the application, what you're doing, these are definitely flushing considerations. It used to be that, we'd flush water, and once it went down the storm drain, it was out of sight, out of mind. We didn't have to worry about it at that point in time, but we really need to be aware of where does that water go? Does it 200 foot down the line daylight into a stream or river or a lake? So these are considerations that we have to make sure we have safeguards for. Next one. Denise?
Got it. Thank you. So with everything Drew said, I always like to emphasize that dechlorination, it's not hard. You just need to know that you're getting the right equipment and chemicals and things like that. So, I always try to unscare you guys because not everybody dechlorinates, though you should, and you never know when those mandates are going to come out and make it mandatory. And it's a hefty little fine and the threat of what EPA can or cannot do to a municipality if you make a mistake. So moving on, we're looking now at flushing tools and equipment. So there's two main publications. Oh, sorry, go back up, my fault. There's two main publications, AWWA Manual M as in Mary 17 and NFPA 291. Those are going to hold all your suggested material and how to do a flow test and measuring and hydrant maintenance and all kinds of good stuff. This is going to be your reference material. If your fire department, I'm assuming you're using 291. That book is about 18 pages long. AWWA M17 is about 170 pages, but it also has a lot of drawings in it for hydrant bonnets and different parts and everything that you need on a hydrant maintenance scale. The publications are identical except for one sentence. NFPA says that it wants a 25% drop from static to residual, and AWWA says it wants a 10 psi drop. So we'll pick that up in another discussion in a few minutes, but just some key things there. So if you are talking to a water and a fire guy, sometimes you're going to butt heads over that one sentence. Other than that, the information is dead on, and it's very helpful. It's always good to have those publications at hand. And the next slide, thank you so much. All right, flushing tools and equipment. I always say that flow testing equipment is a dime a dozen because there's so many different options. Based on what your need is, I kind of classify them as inexpensive and then middle of the road and top of the line. So economical, inexpensive are handheld pedos. Handheld pedos will take a measurement. They're based on the orifice and coefficient of the hydrant nozzle. So it's important to know what your coefficient is. And in the books, they will tell you, measure, put your fingers inside the nozzle and feel it around, and it will tell you if it's smooth or rough or if it has a metal block on it so that you can appropriately figure out what that coefficient is. Most all of your diameters are 2.5 inch, but in Texas, you also have 4 and 4.5 inch hydrants for your pumper ports. But handheld pedos, they'll work for you. They're not my favorite. Holding a pedo in a flowing stream of water, depending on what your velocity is very difficult. Every time you move, you can get a different reading just by wiggling. Again, it depends on what your goal is and how accurate you want to be. I'm guessing your ISO guy comes out and does your flow testing. He's not using handheld pedo. Next slide. So more kits, more items. We have fixed pedos, and these are my middle of the road. Because the pedo is fixed in the device, it means that you're going to get a constant reading. There's always other things that can interfere. These devices hook directly to a hydrant, and the majority of them diffuse the water, which is great so that you don't eliminate property damage. And as I mentioned, we always plant flowers by the hydrant because it looks nice and we want to hide the hydrant. You will rip them out. But again, this is a fixed pedo, so you're going to get more of a consistent flow reading. They are available 2.5 inch, 4, 4.5, and even 5 inch stores. Parts of Texas also have 4 inch stores. So there's a lot of different ways that you can accumulate material that's best for your system. Flow rates also, if you're flowing at 2.5 inch, you can expect to start at 500 gallons a minute and go up from there. If you're flowing off the pumper or steamer port, then you're usually going to average at least 1,000 gallons a minute and go up. You've got some big systems down there. So again, you want to make sure that you have the proper equipment to get a reading so that you can see the needle move on your flow gauge. Always suggest if you're starting a new project that you're going to do flow testing, then get some extra inner tubes or pedos for whatever device you choose to go with. If you haven't moved water in a while, and we all have hydrants that have been sitting there that haven't flowed, then you will rip them out with debris, sometimes just extremely high flows. So always get some backup data or backup equipment so that you're not left high and dry once you start your project. This would be the cat's meow. This is what I call these hose monsters, okay? These are the top of the line because they're FM approved for their accuracy. Most other equipment is not. Currently, this is the only one on the market. The difference between this and the other items that I showed you is that this does not hook directly to a hydrant. This, you run a short piece of hose, 10 to 15 feet, set the unit on the ground like you see in the top picture, and it will shoot the water east and west instead of across multiple lanes of traffic. The hose will not ever pick up off the ground. That's just the way the unit is designed. And again, because they're FM approved, they're going to give you the most accurate reading that you can get. There is a new technology out there, the pedaless nozzles, that work with the original metal classic hose monsters and also the new plastic styles. Those pedalless nozzles are great because there's no pitot to get ripped out during your flow, so you never have to repair them. You may have to replace a gauge and you may have to replace a hose just due to normal wear and tear, but you're not going to be ripping out equipment because you had rocks or debris come through. That's huge, and that saves you a lot of money and a lot of time. So just want to introduce the products to you a little bit just so you can get an understanding, and see some of the things that are available. Everybody has kits. I like to think that Pollard Water has everything known to man, at least the good ones. And again, we'll be more than happy to answer any questions or give you guidance depending on what your goals are.
Just to piggyback on what Denise is talking about there, you could have water mains that have been in the ground for eons versus new construction, and it doesn't matter the age of the pipe. You can throw a rock. It's very common to throw rocks on old and new. It's just one of those things that's the force of nature. So that's one of the reasons why we don't stand in the flow of water, make sure our devices are securely attached. And diffusers with baffles or some form of diffuser. So if you do throw a rock, it's not going to be potentially dangerous wherever it lands. But it's inherent danger to a lot of flow test devices where they do break off the internal protrusions. So looking at some of the pedalless nozzle technology is pretty cool. Moving into other devices that are for dechlorinating. So there's several dechlorinating devices out on the market. A pause again on dechlorination. When we're dealing with potable water, that's our drinking water system. We're talking low chlorine concentrations. We're talking anywhere from 0.3 parts per million up to 4 parts per million. I don't think I personally have drank water anything over 1.25 parts per million. That for me was pretty hot. So we're just dealing with very low concentration versus new construction where they're putting new water mains in and they're having to disinfect those water lines with 50 parts per million. You're dealing with a whole different ball of wax, different chemical and different devices. When you're dealing with tablet devices, so I could say this with a certainty, market-wide, nationwide, competitor-wide, there is no tablet out there that can dechlorinate high levels of chlorine. So when you're dealing with tablet dechlorination, you're dealing with low level only. Just want to make sure that we're clear on that one. Dechlorination is a full day class. We can talk about that for a full day. So dechlorination tablets, this particular device is a flow device. You can hook it either directly to the side port itself, they're lightweight, or you can have it at the end of a length of hose. You can see the upper picture here. It's on a little hitch mount bracket, which is pretty slick because you can drive around in your flushing program and all you have to do is connect and disconnect the hose and continue on flushing. The cool thing about tablet technology is it's lock and load, ready to go. You don't really need to figure out dosing. You basically add a tablet when your tablets get down to about 50% their size. You add another tablet and continue on flushing. There's really a couple common types of chemical out there. Sodium sulfite tablets, very common, been in the industry a lot longer than ascorbic acid tablets, which have came into the industry probably about 20 years ago. And there's a huge cost difference, but there's pros and cons to each. So again, if you're trying to figure out which to use, that's a great question, to work with your Ferguson salesperson or give us a call directly. We can help find the appropriate chemical that works for you and your budget. These devices will flow up to about 1,200 gallons per minute. There is an accessory you can affix to the side of these, and I just want to make sure it's very clear that whether it's ours or someone else's, this is not a flow test device. This is a dechlorinating diffuser. And it was originally designed for this pedo system that affixes to the side to help people from an accountability standpoint. So when you're flushing your water in your flushing program, you're sitting at a particular hydrant for 30 minutes, this gauge will tell you, within decent accuracy, will tell you that you're flowing 450 gallons a minute, and then you can extrapolate with time and then keep a log of how much water you flushed, today, this week, this month, this year in our flushing program. So it's designed for water accountability and not for flow testing. It has not been tested, and we don't have a % accuracy for a flow testing purposes. So accountability, it's great, and it works wonderful. Questions on this device? I know this is pretty popular. You see this out there all the time. Do any of you gentlemen have questions on this device? No? Okay. Pretty
You
cool.
would
Tablets.
just touch on the ability. Do you need to wear gloves when you're handling this product?
Yeah, you know what? It's so sunny here. Hang on a second. I'm gonna do this. There you go. Oh, much better. Thank you. No, tablets, whether it's sulfide tablets or vitamin C, DOT safe, non-hazardous. That's the nice thing about them. Just basic common sense, basic PPE. It's always advised to wear gloves. It's not, if you touch it and handle it wet or dry, it's not detrimental. It's not going to be an issue. You might have skin that's sensitive and it might be an irritant to you. So it's always best to approach, handling of chemicals with gloves, but it's safe chemical. Storage for any chemical, dechlorination or even chlorine, dechlorination chemical will last typically a year, as long as it's stored in humidity controlled room temperature out of UV light. So storage is it's a stable chemical. Conceptually, tablets, it's like soap in a shower. Soap is, you can put that up against the shower head and the soap will deteriorate a lot faster than if you hold it, 2 foot further away. It's going to last a lot longer. So the concept is water goes through these diffusers, the force of water will break the binders off and release the available chemicals. So you have dechlorination happening from the point of contact of water on the tablet to all the way up to the point where it goes down the storm drain. So I'm always testing chlorine residuals, not only at the diffuser, but also at the storm drain to make sure that we're effective. Because you still might test positive right at the mouth of the diffuser because chemicals just been released and you're thoroughly mixing going on. So tablets are safe to handle, absolutely. Now that last device was for a 2.5-inch port. So, and you can, like I said, either at the end of a length of hose or on a hitch. And with the onset of a lot of unidirectional flushing programs and velocity requirements, a lot of people are looking at ways to be able to flush off their pumper ports just because of the velocities they can achieve out of those ports. So having a diffuser and yet a dechlorinating diffuser that can accommodate that. This is another, style that's out there. Again, it's a hitch mount, so it's rather heavy. So being able to have that safely secured to the back of your service truck, and you can't really see it in the picture, but there's an inlet on either side of the device. You pretty much see it on its left side there. But on the other side, it's the same inlet and it's just capped off. So you have an option for that. So that helps, depending on your orientation in the street, it helps with keeping your hose from kinking because you're trying to wrap it around and connect. So it makes things a little bit easier. And again, dechlorinating here, whereas the LPD 250 could flow up to 1,250 gallons a minute, this device can flow up to 2,500 gallons a minute. And accommodates 2.5, 4, 4.5, and you can probably get adapters for stores fittings as well. So that's pretty slick. Both of these will dechlorinate potable water only. So next one. And we talked about dead ends and we talked about chlorine residuals and managing those. So sometimes a possible solution, instead of rolling a team out 4 or 6 times a year to flush a certain string of our distribution system, it might be advantageous to consider an automated flushing system out there. This is just an example of one of many that's available. Technology is pretty cool. It's kind of like sprinkler system programmings where you can go in and go, I want my lawn to be watered on Tuesdays and Thursdays for 30 minutes. And you can go in and inside that box in the picture, there's a little programmer that you can program. So your hydrant is actually energized, it's charged, fully open, and there's an electrical solenoid with a controller in there that will open up and allow it to flush, and you set the frequency. And the nice thing is there's a basket you can put in there for dechlorination tablets, and even some add-on little directional diverters to help with erosion control issues. But there's probably 3 or 4 brands out there of automated flushing systems, and these are, great for those problematic areas that haven't quite made, engineering, re-engineering of the distribution system in that area. So you're still having to deal with it. But this is something to consider when you're doing your flushing. Next slide. Before Denise jumps in here, a couple things I just want to bring out. Maybe I'm stealing a little bit of your thunder, Denise, and that is when you're doing flushing, it goes without saying, when you operate a fire hydrant, you want to make sure that you operate a fire hydrant fully open or fully closed. A hydrant is not designed to be valved or throttled by means of the operating nut on the hydrant itself. Hydrants are fully on or fully off. You can regulate the flow by 2 means: a gate valve that you can add on to the outlet, and or from the auxiliary valve in the street. Those are the 2 best practices for throttling the amount of flow coming out of a hydrant. Now, when you're doing flow tests, Denise, she'll add on to this too. It's not always, the device, it may not be advantageous to use a gate valve, because a gate valve itself may change the flow characteristics. And so if you have a gate valve and then a flow test device, that could cause a problem. So in those cases, it might be best to, really when you're doing a flow test, you really want to see what 100% is, right? So you're really not throttling back. So this may be a moot point, but if need to, I would throttle from the auxiliary valve in those applications. Denise, do you want to add on to that, or?
No, you said it very well. Auxiliary valve is definitely the way to go, because sometimes you can't open a hydrant wide open, especially in Texas. You've got some big systems out there. So you are maxed at what the flow device is going to let you flow, so that you don't peg your gauges and break them. So sometimes you can't just open it wide open and go. Sometimes you have to back off in order to get an obtainable flow and read the gauge. Is there anything else you wanted to add, Drew?
No, I think that's great. Thank you. I just wanted to kind of throw that in there before we jumped into your next slide.
Sure. So now we're going to talk about data loggers a little bit. Data loggers are extremely helpful for multiple reasons. Data loggers have 2 main functions. One, you can attach one to your hydrant as a cap to take your static and or residual. So we're just going to kind of school for a minute here. Static is the pressure of your system without any water being discharged. Residual is the pressure left in your system while you're discharging water. And your discharge is your flow rate, which is taken from a different hydrant or a different port. So your cap is going to do 2 things at the same time for you. When you take that residual reading, you're going to take your flow at the same time. Data loggers come in real handy if you are with the fire department and you only have 1 person and you need to do a 2 hydrant flow test. You can put a data logger on your pressure hydrant, which is your test hydrant, and obtain your static, which is going to be the highest PSI. And then when you start flowing the other hydrant, your residual is going to be the lowest PSI. And the data logger is going to record that data, so that when you're done with your test and you've taken all your equipment off, you can go back to the office, or sometimes there's phone apps, smartphone apps, there's Bluetooth options, there's all kinds of neat technology out there right now, but you can get that data, you can get those numbers, and that's really helpful for you. So that's one of the main things that a data logger is going to do. Again, it's going to record everything. You can set how often you want them to ping. You can take a reading every 2 seconds, every second, every 10 seconds, every 30 minutes. The other reason that data loggers are so helpful is if you have an area of town that you think you're spiking or having low water pressures, residents are calling saying that they're not getting enough pressure out of their showers and things like that. So you can attach a data logger on the nearest hydrant and set it to record X amount of times pings. And then you can go ahead and leave it out there for a couple days, come back and get the data. And then you can see what your system is doing. So the graph that you see is a pretty simple graph. It just shows that water was being used and suddenly it spiked. So then you can start investigating. Data loggers, there are impulse versions that are a lot more sensitive, and they can help you find leaks in your system. So accountability is another area to have a data logger for. Data loggers come very basic. And again, the new technology that's out there is Bluetooth, wireless. Some are very cost effective, some are very expensive, durability. So all kinds of things just to make your job easier. That is the final goal. You're fine, thank you. You can switch. All right, so let's talk about software. So earlier I talked about static, residual, and flow. So there's a couple of things that you want to do when you're going to do a fire flow test, okay? You're going to take that static, residual, flow, and then what are you going to do? So you can calculate it by hand if you have the formula to do the extrapolation out of those manuals, or you can use a software program that will do it for you. That's the easy way. The software programs are also very convenient because besides entering your static, your residual, and your flow, you're also going to enter the orifice size of the device or the hydrant nozzle. It's one or the other. If you use a device, you use the coefficient and orifice size of the device. You do not use the hydrant. You also enter how long, so once you enter the coefficient and the orifice size, there's a start-stop button. You can hit start and start flowing water from your other hydrant or other port. The software, when you're done, you say calculate, and it will tell you how much water you used and calculate your extrapolations out to give you what your predicted flow is at 20 psi. So the important thing is this, is getting the proper data to use a software program. And again, every flow device has its own coefficient and orifice size. Flow charts, I'm sure you all know what flow charts are. They are not intermixable. We have a hose monster, we have Acron devices, we have Hydrant Pros. You cannot intermix those flow charts because each one is different and you want the most accurate data that you can get. And that also helps you if you're going to go out and do unidirectional flushing. It's not quite as critical because you're doing guesstimations. So just like using the LPD 250, which has a very different coefficient, it's good enough to get you a predicted flow of velocity to scour mains. So again, once you decide what you want to do and how far you want to take the program, then you can decide and again, figure out what equipment that's best for you. And the next slide. So hydraulic mapping. So here's the basics. We've talked about hydraulic mapping and how to set out your system and things like that. The easiest way in my little world is like this. So you take a small section of town and start small, whether it be a subdivision or just a 5-block square radius. Take the first hydrant in line, regardless if it's the largest main or maybe at the very edge of town. So you're starting by a tank or a tower. And that's going to be hydrant, we're going to call it XXX001. Okay, that's going to be your test hydrant, your pressure hydrant. The hydrant next in line on the same lane is going to be XXX002, and that's going to be your flow hydrant. So then you go out and you do your test. When you get your data and you're done, now you're going to go hydrant XXX002 is now going to be your pressure hydrant, and the next hydrant, 003 is going to be your flow hydrant. And that's how you do things in walk order. And again, a lot of you already have your mapping systems, blueprints, whatever you need so that you can set up these areas. I will admit the first time you do it, it's a little tough. And when you actually get out into the field and the guys are walking this path, you say, hey, there's a hydrant there that we didn't know about. Things like that. Hopefully you have hydrant IDs and, hydrant tags and all that good stuff to make it easier. But this is the time that you can create new SOPs. You can do work orders when you notice that you're taking a hydrant off and the cap's not coming off or it's missing, things like that. So as you grow, that's why I say, as you grow, it will get easier and easier. The first time you do it is a little tough, but start small and take a small section of town. Do you guys have any questions yet? You're so good. Well, I'm pretty much done with what I have. Drew, what do you have?
The only other thing I can think of is when you're doing flow testing too, and if you are the one doing the flow testing, it's best to use the same equipment from start to finish so your data is all relative, and that doesn't affect your percent accuracy. Do you concur, Denise?
Politely, no.
No? Okay,
Yeah,
good
and
discussion.
the reason is because on the software, you have the ability of putting in the proper coefficient and orifice size. So
Okay.
depending if you're using a 2.5-inch unit versus a 4-inch unit because of the velocity that you have on the line, now you have the ability to change that equipment out because you're still entering the proper information on your SOP worksheet or software program. So as long as you're accountable for the equipment that you have and make it easy for the person that's going to do the extrapolation, you're good to go. And there are situations where at times on a very high system like you have, you may have to flow 2 outlets from the same hydrant or even 2 hydrants in a row in order to get that drop from NFPA or AWWA. So it's not uncommon, especially on a gravity system up in the mountains. It's not uncommon to have to open 3 or 4 hydrants just to get that drop. It depends again on how far you want to take it. But these are the things. The most important thing is getting your mapping started so at least you can start flushing water and moving water and helping your customers, your residents, have clean water on a regular basis. The one thing that I do want to mention is there is a product on the market is called Red Be Gone. It's not uncommon when you start flowing water that you're going to get customer complaints because they have rusty water. And if you make a mistake and you go the wrong direction and then you come back and do it again and somebody's doing their laundry, I guarantee your phone will be ringing before you can get back to the office. Red Be Gone has a way of eliminating rust from wash. As long as it hasn't gone through the dryer, you can re-wash your clothes and get that rust out of them. It's available in multi-purchases of like 8-ounce little bottles. It's nice if municipalities have a case of those and hand them out as needed. There's also signage that you can use, whether it be a sign, a tripod sign that says, flushing tonight or blah, 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 whether it's, doorknob hangers, things like that. Get your community involved because when you start flushing water and they're upset because you're not able to wash their car or water their garden because you've got restrictions on, they need to understand water's a high commodity, but flow testing and unidirectional flushing do not get the recognition that they need, and it's critical for fire life safety that you crack open a hydrant and know there's water coming out. Sorry, that was kind of my spew.
No, that was well said. Good job. Questions, please.